Hello! In today's video, we will be talking about intermediate OpenRocket. This video is one of two videos. Both videos will be talking about OpenRocket. For this one though, we'll be talking about shapes, materials, motors, and multistage. Be sure to check out the next video though. It's covering off further simulation analysis and also automatic optimization of rockets. Alrighty, let's get into this. Here I have a blank page. However, I'm going to open an example. Alrighty, we're going to take a look at the nose cone. In here we can see the nose cone shape. If you're buying a nose cone, try and match this up to whatever you're buying. Now, if you aren't buying a nose cone, I would recommend messing around with the nose cone shape to get the best performance of what you want. For example, if we just go through all of these, we can see that the shape is changing and the apogee is also changing. From this, I can see that the conical has the highest apogee. Keep in mind that if you are making a custom nose cone, you need to make sure that you can actually make it with the CAD software that you have. For this reason, my favorite is the Hark series. This nose cone is difficult to make in Fusion 360. However, it is doable, and this is my favorite nose cone as it strikes a balance between apogee and stability. Now, do not forget the nose cone parameters, and make sure to get the component material and component finish correct. Let's say that we're going to make a nose cone out of TPU. I'll go into here, go into component material, but if we look in the T area, it's not there. What we can do is we can press custom, and we can name the material, and then we need to find the material density. Now to do this, we need to go to the internet on a web browser. Here I have searched for the TPU filament density. We can see here that it is 1.21. Make sure that the units are the same though. If we go back into here, now I can just copy the material right into there. Let's type in 1.21. And then we go add material to database. Now we can see that it's there. Okay, now we're going to change the motor. We'll go to motors and configuration, and I'm going to add a new configuration. Now in here we can also select the specific motor manufacturers that we want. Alright, now I changed the total impulse. I'll make it from B's to D's. Now this is how you filter it. In here we can see all of the motors from different manufacturers. I'm going to clear all and add one specific manufacturer. Let's say Estes. In here we filtered it out so we can only see Estes smaller sized engines ranging from B to D, with the motor dimensions being 18 to 24 millimeters. Don't forget that the motor diameter is important, and make sure that you get it correct. Let's say while searching for motors, you can't find the motor that you want. You can import an engine from thrustcarve.org. Now do keep in mind that whenever OpenRocket updates, it imports all of thrustcarve's database. Now to change the units in OpenRocket, you can go into Edit, then Preferences, then Units. In here, you can change things to metric or imperial or whatever you want. Okay, I'm going to open an example. Here we are. This rocket has 2 stages. We can see here that it shows the stages here. The very top stage is called the sustainer. It's the main stage. Anything else is called a booster or stage 1, 2, so on. Usually, the sustainer is the highest number of stage. So if you had 3 stages, stage 3 would be the sustainer. However, since we're only doing 2 stages, the sustainer would be stage 2. With the stages, we can hide or show either booster or sustainer, whichever one that we want. Okay, now let's look at the center of gravity. We can see here that while the booster is burning, the center of gravity is here. The stability is 2.09 cal. I would usually go more than that, but this is an example. Now, let's say that the booster is separated, so I'm going to click on booster to hide it. Now we can see here that this is not very good as it is 1.7 cal stability. But keep in mind that the rocket is still technically safe because the center of gravity is 1D apart from the center of pressure. Now I'm going to show you how to cluster. Now let's take a look at this clustered rocket. Again, I have chosen this from the examples. Here we can see that in the flight configuration it says 4 times C-67s. This means that he has chosen 4 engines. If we want to see that, we can go into View Type and change it to 3D Figure. Now we can drag around and see that it has 4 engines. The thing about clustering is that it can be difficult for igniting multiple engines at the same time. Sometimes what happens is one engine ignites late and then your rocket tilts to the side. I hope this tutorial helped you gain a deeper understanding on how OpenRocket works and its deeper features. See you in the next video.